All right, so this is a picture of all of the robotics faculty at the University of Michigan. Here, obviously, robotics is a very heavily interdisciplinary field. And at the University of Michigan, we have over 40 faculty across a wide variety of departments. So they're sort of concentrated in engineering, electrical, mechanical. I'm in biomedical engineering. But also collaborating with, there's also members from other schools around the university. So the School of Kinesiology, Physical Medicine, Rehabilitation, and a lot of other collaborations with the hospital. And this is a growing area here. This is just an example of the hires in robotics for just the last 2 years. Jason Corso came to us from Johns Hopkins, and his lab focuses on computer vision and robotic perception. James Forbes is in aerospace engineering, and he works on control systems and space robotics. Matthew Johnson Robertson works on 3D mapping and vision, and also underwater autonomous vehicles. Dimitra Panajo came from Athens into Aero, and she works on multi-agent systems and motion planning. Ram Vasudevan, he was hired in mechanical engineering and has a lab focused on human-robotic interaction. And finally, Jia Deng came from Princeton into computer science, and his lab is focused on artificial intelligence and computer vision. So here we have a big tent approach to robotics. We sort of define it as anything that has an embodied computational element. So it can be autonomous or semi-autonomous, humanoid or vehicle. And we're bringing this together into a new vision of a robotics institute. And so this will probably be divided into different focus areas, such as autonomous vehicles, biomedical and rehabilitation robotics, and some of these other categories here, though these are just examples. And I'll talk about some of the different labs that work in all of these different areas in a few slides. We're also very excited about our new robotics PhD program. So it's now actually possible to come to the University of Michigan and get a PhD in robotics. The educational program is divided into core areas focusing on sensing, reasoning, and acting. We've developed 2 new graduate courses, so a robotics boot camp for students coming in, focusing on the math and some sort of the hands-on aspects of robotics. We have our first class that started last year, and it includes 5 PhD students and 3 MS students. And actually this year we had almost 300 applicants for the fall 2015 class. The long-term goal for this program is eventually to build up to 15 PhD students per year and 25 master students annually. We're also very excited about the new building that's being planned for robotics. I talked about there's a lot of faculty all over the College of Engineering, and this is an opportunity to bring them together into the same common space. And so there will be new space for instructional labs and new space for research all in the same building. So there'll be new labs for walking robots, flying robots, autonomous cars. And also, you'll hear more about this in a minute, but construction is also finishing up on an enormous new test track for autonomous vehicles. It's just a few blocks over there. Construction is nearly completed on that, and the planned launch date is in summer 2015. So we're planning a lot of cool things for the future within the Robotics Institute. So we've been co-organizing Robotics Day for several years now, and it's undergone huge growth from originally 150 attendees, 525 last year, and we'll announce a count at the end of the day, but close to 700 participants this year. Other things in the works for the Robotics Institute, we're going to introduce new student group programs. And also a seminar series where we can regularly bring in outside speakers and also have internal professors give talks. So now I'm going to go through and just highlight a subset of the different labs at the University of Michigan. So I'm going to go through this fairly quickly and just give you an overview of what these labs do. But a lot of these faculty or their students are around today, and so definitely feel free to contact them if you have questions about or interests in this kind of research. So the Arose Lab focuses on autonomous vehicles. And they do this in a realistic setting where there might be limitations on the communication, so you have to be able to deal with interruptions. The Olsoy Lab also is seeking to improve performance and safety through better systems modeling and control for autonomous vehicles. And as we heard earlier, self-driving cars have the potential to be even safer than human-driven cars with things like autonomous obstacle avoidance. Jeff Stein and Tolga Ersal also work on hazard avoidance algorithms and find good ways to enable vehicles to then maneuver around those obstacles when they encounter them. Some of Ed Olson's autonomous vehicles will be around here today, and the focus of his lab is creating effective human-robot collaboration. So imagining that you were one person coordinating a fleet of robots. This is an exercise in cooperation, again, where the whole is greater than the sum of the parts. The Perceptual Robotics Lab works on autonomous underwater vehicles for both basic science applications and also defense applications, and also works in the area of self-driving cars. And as you heard in the panel earlier, there's a lot going on with drones at the moment, and this field has been growing dramatically over the past few years. Ella Atkins in aerospace, who is on the panel, her lab focuses on improving safety and robustness of unmanned aerial vehicles, for example, so that they can cope with unexpected changes in their environments. Moving towards humanoid robotics, Jesse Grizzle's lab focuses on bipedal locomotion. So this is Mabel on the left, who is the world's fastest running robot with knees. Mabel needs a little bit of support from that boom that she's attached to, but Marlo, down on the right, can be free running. David Remy also works on locomotion, and his lab looks to biology to figure out how to design and optimize legged robotic systems. So you can see in the upper left, there's a picture from one of his prior studies on horses to develop a robot with quadrupedal locomotion. Dan Ferris is part of the Rehabilitation Robotics group. His lab is actually in the School of Kinesiology, and he focuses on robotics for rehabilitating the lower limb. So for example, lower limb exoskeletons for rehabilitation, and also powered lower limb prostheses. Not listed here, there are also two other labs in mechanical engineering that focus primarily on rehabilitation robotics. So Art Quo's lab also does lower limb exoskeletons and studies walking. And Brent Gillespie, also in mechanical engineering, focuses on upper limb with upper limb exoskeletons and prosthetics. And that lab focuses heavily on sensory feedback and how sensory feedback can be used to improve the use of prosthetic limbs. So this is me. I work on an area called cortical neural prostheses, and we actually implant many small wires into motor cortex to record the activity of neurons, and then we use that activity to create command signals for motor devices. So that might be a prosthetic limb, it might be an exoskeleton, or it might be using electrical stimulation in a paralyzed limb. So this involves a lot of software because we need better machine learning algorithms to interpret the neural code. And it's also a hardware problem because we also need better sensors, and we need very, very small implantable electronic devices to interpret the activity of the brain. Don Tilbury, who just spoke, in mechanical engineering, studies robotic teleoperation. And that includes incorporating semi-autonomous behaviors, where you have a human and a robot sort of working in tandem with some intelligence coming from both to improve the overall performance. Research in the Human Motion Simulation Lab, which is in Industrial and Operations Engineering, is focused on algorithms for accurate and fast prediction of human motion. So they want to simulate how humans interact with engineered systems. People are interacting more and more with robotic and automated equipment, and this has to be safe. So imagine that you could have a robot that has knowledge of normal human motion, and they can detect and respond to any unusual events or error states. Ken Oldham in mechanical engineering studies micromechatronic systems, or microrobotics. So they model, build, and test these little guys here, most of which use piezoelectric actuation in order to move. Emily Maurer-Provost is adding an emotional dimension to robotics. So if you've ever called into an automated voice system for something and found the voice to be very unsympathetic, that's a problem that she's trying to solve. Her lab works to mathematically characterize emotions in conversation and ultimately use this to improve the interaction between humans and robots. The Saito lab focuses on reducing energy consumption in manufacturing robotics. So imagine that you could coordinate the activity of different robots in a way to maximize your energy efficiency. Kira Barton's lab also focuses on manufacturing robotics, particularly in tasks that require high speed and high precision. So for example, incorporating new kinds of sensors and learning strategies in order to improve the manufacturing process. Vineet Kamat is in civil engineering and focuses on automating construction tasks, so in things that involve civil architecture or civil infrastructure. For example, the Smart Dig project uses computer vision to localize buried utilities so that you can excavate in a more safe manner. The goal of the Interactive Task Learning Lab is very much focused on artificial intelligence. So their goal is to create autonomous agents that can be taught new things in a very intuitive manner. So imagine that you had a robot that you could teach by talking to it and demonstrating things the same way that you would do with another person. And finally, let me talk about two faculty who are new this year at the University of Michigan. Jason Corso in electrical engineering has a lab focused on computer vision. And particularly on visual understanding. So you might be able to record an image on a camera, but then in order to understand it, you have to work on automated segmentation, recognition of particular activities, and even taking that video and turning it into a text description of what's going on. Ram Basudevan was recently hired in mechanical engineering, and his lab is focused on human-robot interaction. So, for example, robotic prediction of human behavior, and then trying to apply those predictions to making things safer. This also has medical applications. For example, you could imagine using this for automated diagnosis or rehabilitation. So that's my last slide. You can see we have a wide variety of labs here from a wide variety of different departments, but they're all very engaged in the robotics program here. And this is all coming together in the plans for the new Robotics Institute. And so again, we're very excited about our new robotics PhD program and also the construction of a new robotics building that's in the works for North Campus. And we're looking forward to bringing together many of these groups under the same roof. And definitely stay tuned for more big announcements over the next year.